All right, problem five. I thought I'd get fancy and talk a little bit about some of the atomic models we deal with. So we have two models that treat atoms like like atoms as having electrons that orbit the nucleus like planets. One is the Bohr model, and one is the Rutherford model. Now, I guess if you really talk to physicists, they'll say, well, the Bohr model is kind of like planets, but not really, since they can jump orbits. But um, it's it was a fundamental kind of he used planets as his basis, and it was sort of like they could jump from one level to another. So we'll say C and D. Now, both of these models assume that electrons only have certain energy levels in the atom. That's the modern quantum mechanical model and the Bohr model. And then in this model, the third one, no internal structure at all, that is Dalton's solid sphere model. Let's be really clear on this one. He actually borrowed this from the Greek philosopher Democritus. I think I said that in the last video. The source of our word democracy. So um, Democritus was very poetic about it. I guess he talked about, you know what, I think I mentioned that in the last video. I'm not going to repeat myself. I'm becoming like one of those old people that tells the same story over and over. All right, and then in this model of the atom has a mix of positive and negative charges distributed throughout the entire atom. That is our plum pudding model. That happened after J.J. Thomson discovered the electron, and we realized that that was actually a thing. So, and then in this model of the atom is a mix of positive charge and, and then the very last question, the most accurate model of the atom that we actually have to date is, in fact, the quantum mechanical model, E, that is kind of at the forefront of physics and chemistry as far as our models of atoms go. Forefront of physics has actually gone beyond the structure of the atom, but there's an entire branch of chemistry that uses this model in doing day-to-day calculations. So that is problem 5.